Hey guys, welcome back. So today we got a 2014 Santa Fe. Um, it's a 2 liter, 535 kilometers. Customer complained about check engine light. The history of this vehicle, they replaced the sensor, and I jot down our codes before 2271 P0136, and I scan it, and they're the same. We have the same code. So I went to a history for what part that they replace, and they replaced the bank 1 sensor 1. So I'm gonna double check that if they really replace the bank 1 sensor 1 or they replace the bank 1 sensor 2, so meaning the downstream, because as per this code right now it's pertaining to our bank 1 sensor 2, the downstream. So we're just gonna, what's the other history? Okay, that's the only history we have. So you can go to our data, and let's see what's going on this reading, because it's saying stock clean or stock rich, and there's no activity on it, right? So we got here upstream, downstream. What else do we have? We'll check this auto sensor ready for operation. Okay, so we're gonna start this. Let's go graph. So right now we're just waiting for it because the engine is cold right now. Okay, so bank 1 sensor 1, the upstream, right now it's showing on. So but our downstream right now staying at 0.4 millivolts. So we'll just wait until we're on the operating temperature, and because of those codes I can also smell the rich condition. So as per the code, they're saying that it's stock rich on the the downstream sensor. So it could be that it's what do you call that, um, injecting more fuel, because we have also a stock clean code. So I'm just gonna let it run for now, and if I can see our downstream as per the computer that he wants to turn it on or it's ready for operation. Let's see this data here, if it's turning on or not, and then we can do some snap throttle and see our response on our auto sensors reading. Okay, so I'm just playing around with the throttle. At least it will help us for the temperature, operating temperature, to go up. So right now we're at 87 degrees. Our downstream operation turns on, and as I can see here on our voltage reading, it's staying at 0.4, right? So right now I'm revving the engine at least 2000 rpm, but once you let go of that pedal, those sensors should go lean, right? Because it's cutting off fuel. So right now I'm gonna raise it. Once I take out that gas pedal, as you can see here on our upstream, which is reading correctly, it goes up because there's no fuel, there's cut off fuel there. But on our reading on this downstream is staying at 0.4. Maybe it could be this is just a, what do you call that, a substitute value. So what we can do too is we can go to the OBD2 side, and let's see what's the reading in there. Yeah, so it's just staying at 0.4. So let's go back to the main menu. I'm gonna go to the OBD2. Okay, so I'm gonna go first the diagnostic trouble codes. Okay, so all codes are pertaining to our bank 1 sensor 2 downstream and saying that it's lean, right? So now I can go to our current data, because most of these newer cars, let's say this Santa Fe, that bank 2, or not bank 2, the downstream also a fuel trim, we call that input too. So let's go here. I'm just gonna check our short term, right? Long term, our bank 1 sensor 2 downstream, and then our bank 1 sensor 1, which is the upstream. I'm just gonna graph that. Okay, so now I'm just gonna raise the RPM. So right now, when raising the RPM, my downstream should at least read that 0.8, 0.7 volts, right? Or 0.9, because we're putting more fuel in there. But there's nothing at all there. It's staying at 440 millivolts. But our upstream is showing minus 0.35 milliamps. So that's the rich side of that lambda sensors, right? So if I'm gonna let this go, I should expect this milliamp reading should go up and our millivolts will go down, because that's the lean side. So as you can see there, it went up, but it went down only for 10 millivolts. So as you can see here, it just went down, not all the way zero, because that should go down all the way zero. I'm gonna try that again. Raise the RPM. Stuck at 455 millivolts. Now if I'm gonna let it go, that should go to zero. I stuck at 380, right? So now the question here is, do you have a faulty sensor? Is our scan tool reading it correctly, right? So we're gonna go to bank downstream sensor and check our circuit. So I don't know if I can open the schematic diagram here. Let's see. So I guess we can open it. We'll just eliminate some stuff before we go onto that route. Okay, so okay, oxygen sensor, no oxygen sensor there. There. Okay, so we have oxygen sensor here. So as you can okay. So as you can see right now, we got our upstream here, oxygen sensor. We got power here, sensor 1, 15 amp, and they share the same power on our downstream. So I don't think that we have a problem with the sensor to cause that no activity issue on this sensor downstream, because that sensor will power up this upstream. But still, we're gonna double check this connector here. Maybe there's a broken wire in between here, this pin 5 and pin 4 going to our sensor itself. We'll check that, and then what else? We can check our control for the heater, if the PCM is controlling that, because if the PCM is not controlling that, let's say there's a broken wire or the PCM is not controlling, the heater will not work and we get a problem with our sensor not reading correctly. So we're gonna double check those, and this is our signal, and compare, see if it's really reading that 450 millivolts, right? If our scan tool is reading correctly. So I'm gonna lift up the vehicle and let's just do visual inspection Make sure that there's no leak also on that exhaust side, especially where the sensor sits, right? So yeah, and then we're gonna hook up our test leads and then we'll monitor the readings. Okay, so as you can see, there's some garbage there. Oh my goodness. I think the fuse, the connector location is in here. So we're just gonna pull that out. Just trim piece. We put the light in. Okay, so our concern connector, not concern connector, but our connector that we need to do some testing is this guy here. So let me remove that clip there so that I can just pull that what do you call that, that whole connector there. Okay, so where's my scan tool? Let's confirm our wire colors. So here in our scan tool, or my wiring diagram, as you can see there, there's orange, that's our power feed, our ground control for that heater, yellow, red, black, and white. So on this side here, I can see that we got orange, yellow, red, black, and white, right? So first we're gonna do the test and make sure that there's power going in. Okay, so I'm just gonna use our small scope here, the mini scope. I'm gonna put our meter reading there. Okay, just gonna put it there. So one lead should go to your ground, good ground. So I'm gonna use our maybe door checker. Let's see if it's just a good ground, but we'll check. And then we'll go to that orange wire. Orange wire will be the white here on this side. So ignition on, that should have 12 volts there. Okay, so we got 12 volts there. As you can see, it's reading 12 volts. Now, just to confirm with the heater side, if I'm gonna on this guy here, so if I'm gonna move our lead to our yellow one, ignition on, I should still see 12 volts, right? And until the computer will ground it, that's the time we get that ground control. But from here, fuse 12 volts, and it should pass 12 volts, right? At least we can see properly if we have an open circuit on our heater. So that's gonna be yellow. I'm gonna just take out that lead, and then that's the down, the other side of the wire, the white one. Okay, so in there I still have 12 volts, right? You can see my line there, it went up. Yeah, 12 volts. Okay, so now next is, do we have a ground control now, right? Does the PCM has the ability to make that heater circuit work? So I'm gonna leave that pin there. Okay, now once I start the car, this signal will go down and it's gonna, make that waveform like a signal ground, right? So let me start the vehicle first. Okay, so as you can see there, our PCM has that ability to ground that circuit, right? I can see it's pulling to the ground until the time that it's warm up. That's the time he doesn't want it to do it, right? To turn it off. But it's always there to maintain that temperature so that that auto sensor will read accurately, right? So next is we're gonna go to our signal, right? The white one, and let's see if we have the same voltage there, 400 millivolts. That's what the scan tool said. White one, that's on the top. Okay, so on the top, I think I have to use a sensor ground on this one. So sensor ground. Okay, let me adjust this guy here. Okay, so as per this reading, is it my connection? Why is it moving around? So right now there's some spike there, right? But the minimum reading there is 0.39 volts and the maximum is 4.4 volts, which is that good? And let me do some snap throttle and see if we can. Yeah, so let me do some snap throttle if that's gonna change. Okay, it doesn't do anything at all. It's just a spike there, but this guy here, once we were doing something. So let me just raise the RPM and see. That should go lean. Little gas and that should go lean. And that small down there, where's that guy? Oh. Where there's no reading there now. Okay. Why there's no more reading there? Did I do something wrong? I just reset that quick. Meter. Voltage max. Okay, so right now I think the scope is seeing something here. This is my measurement here. That line is reading 430 millivolts, right? The same thing as our scan tool, but since our scope is very fast in reading, that's why it's reading that spike and going down. But at least if I'm gonna do some snap throttle, we should have some activity there. You can see there it just dropped by, and now it dropped there all the way down. It dropped again all the way down. Can we see it that it's stuck lean? It looks like it's stuck lean now. So if I'm gonna move this cursor, let's measure that reading there. That side is 56 millivolts, so almost zero. So that's why we have a code for a stuck lean too, right? Sometimes stuck rich, but right now that should not be reading like that if the sensor is working, because we're at idle, right? And during our visual inspection we cannot find any leaks. So okay, so right now I can say that we have a faulty sensor. Now I'm just gonna go back to our heater side, right? That's the yellow one. I'm just gonna make sure that we still have control there. Yeah, so we still have control, because I don't want that we get a problem because of the control, or it's not controlling that heater circuit, right? So at least we check here that we got a good control, good power going in, but our sensor is just reading stuck lean, right? As we can see under scope, it's reading 0. And we just did this just to verify that our scan tool really didn't give us a wrong numbers there, because sometimes scan tool is not right correct, because it's a process, right? It's a process data. In here we're testing the sensor itself, how it give us the reading. So I'm gonna go back here. Let's see what's the reading still. Yeah, still reading that. Okay, so it went back to 400 millivolts, but during those times went lean, right? So 440 millivolts. Yeah, so we got a sensor problem. So I guess we're gonna call this that we're gonna put new sensor. Let's verify our repair, make sure that voltage reading when we double check our repair. Once I put the new sensor, it's reading from the maximum at least 0.9 and to the minimum at least 0.1 or 100 millivolts or 900 millivolts for our downstream. So let's see if it is a go ahead with the repair, because they put already a new sensor but it's in the upstream. If not, I guess this is the end. At least I show you guys on how to check that sensor and how to verify our wiring integrity or anything. So I hope you enjoyed that video. Alright guys, so I went ahead and removed our connections inside, as you can see there. Alright, now I'm just going to remove this. Clip here. Okay, so I'm just gonna hit this sensor. Wait. Okay, I think that's good enough. So I'm just using a 22 millimeter wrench. Okay. Be careful because it's gonna be very, very hot. So. So here's our old one. It's all carbon stuff in there. I'm just gonna double check inside here. And see anything in there. Now let me grab the new one. Here's our new one, right? So, yeah, before you also remove, make sure that you have the right part, because sometimes parts supplier will give you the wrong one. So, yeah. Now, I'm going to install this now.
I like it.
That's good enough. And just gonna push this in, the connector inside there. Okay, so I'm just gonna lower the vehicle and go inside the car. And then I'm gonna show you where that harness is located. It's under the carpet on the passenger front area. And that should be it. Okay, as you can see, so it's under here, our harness. So make sure that you push it in first before you install that. And then we're just gonna plug this in. I know you will not see anything because I'm putting the camera in the best position that there's no garbage. So I'm just gonna clip that in. Put our connector there. Yeah, that should be enough. Just push the carpet, push the garbage, and then just put your side panel filters. There you go. So now we're gonna go to our scan tool and let's verify our repair. Okay, so I'm just gonna clear the previous code because I didn't clear that last time. We go to DTC. Go to our history, erase. Okay, now we're gonna go to our data, and then we'll just grab those four datas. So we got our upstream, our concern downstream, and then the operation on and off. Put the graph, and then we're gonna start the vehicle now. So these models, right? Especially replacing emission related components, um, usually it will take at least 2 driving cycles. So I'm just gonna warm up this vehicle, and then let's see if our downstream auto sensor will read correctly now. Alright guys, so after warm up, as you can see on our water temperature is 90 degrees Celsius. Our upstream reading correctly, like what we tested before, and now our downstream is reading at 0.7, as you can see there, right? So we're just gonna do and check our sensor if it's going to the at least 1 millivolt, right? 0.1, no, not 1 millivolt, 100 millivolts. At least if it goes reach, at least we're checking the range of the sensor, right? So I'm just gonna raise the RPM at least 2 or 3,000 RPM. So as you can see on our downstream, it's reading steady, which is good, because if it's not reading steady, you can see it's like mimicking the upstream. You could have a problem with your catalytic converter, right? So once after I raise the RPM, if I'm gonna let go of gas, our downstream should go lean because it's fuel cut mode, and our upstream should go lean too, as meaning it's going up because the upstream is reading reverse compared to our downstream, right? So unlike before, even though we raise our RPM and removing our pedals, so at least right now I'm putting more RPM there. It was reading 0.8. Before, the reading was just staying at 0.4, maybe 0.3, but it's just staying in there, right? So I'm gonna let go of gas now. So as you can see there, our voltage drop on our downstream staying at 0.1, which is good, and that should recover and go to its normal reading when it's 0.8 and 0.9. So at least now we know the range of that new sensor is reading correctly, because sometimes new sensor doesn't mean that it's good, right? So make sure every time you replace something, check the operation of it. At least you verify the repair and you're confident on your repair too, right? So I'm just gonna go for a quick drive on this vehicle, make sure everything is good, I don't hear any abnormal noise, so that I will not get a comeback, even though I'm not repairing other noises, but just to make sure, right? So and also some of this yeah, I told you guys earlier about the components and the emission system, that it takes at least 2 driving cycle. But as the reading right now, I'm confident, I'm happy on how our downstream operates right now. So I'm just gonna tell the customer to monitor it, right? And that's about it. So I hope you guys enjoy this diagnosis on the downstream auto sensor. You can do this in any car as long as you get a good scan tool that can read the datas, and you have maybe a multimeter or a scope if it's good, so that you can also check the sensor itself, right? If our scan tool is not lying on the reading, right? So yeah, see you next time, and thank you for watching.